Welcome. In this video, we are going to order the derivative, that is each of these derivatives, using this curve in ascending order. So that's from smallest to largest. So let's begin by figuring out or estimating the slope of this curve when x equals 4. And why x equals 4? Well, this tells me here x equals 4. So that is this point here. So I'm going to take a ruler and I'm going to do my best to match my ruler up. And actually, since I can't show that on the screen, I'm going to pretend this is my ruler. So here, if this is my ruler, I'm going to rotate and move my ruler until it has about the same slope as this curve. So that looks about right there. All right, so now that we have this line sketched, we can approximate its slope. So remember, slope, that's equal to the rise over the run. In essence, it's the change in y over the change in x. And then just to be clear, this here is the y-axis and this here is the x-axis. So now I'm going to pick a spot. I'm going to start here and I'm going to go down and then over. And let's see, what is this distance? It's larger than 1, but not quite 2. I'm going to estimate that it's about 1.9. So the change in y, I'm estimating to be about 1.9. And the change in x, I'm estimating to be about 1.4. That tells me that the slope in this case, that is f prime of 4, is about 1.9 over 1.4. Oh, and I left one thing off. This is not 1.9. 1.9 would imply that it was going up in this direction, but it's going down, so this should be a negative. There we are. Let me put that negative there. So this slope is about 1.36. Now you don't have to be so thorough each time. Let's just look at these without being so thorough, without making numerical estimates. So let's find another slope where the slope is negative, like this one, which of course I left off again. So I'm going to make that red here just so that I don't forget these negatives. There we are. So let's find another negative slope. I made a copy of my ruler so I can leave that there. On your end, you can just sketch. So when you get your ruler, make sure you sketch a line. Let's look at 0. At 0, the slope is certainly not positive. Excuse me, negative. What about at 2? No. At negative 4? Oh, yes. At negative 4, the slope is also negative. So let's try to make this line have the same slope of the curve there at negative 4. And so here's that point. When x equals negative 4, our function's output is about negative 1. And now let's determine, is this slope larger or smaller? As is it more negative or less negative than our original slope here? So we can compare these two lines. Does this line look steeper or is this line steeper? If you said the slope, that is the slope of the line passing through 4, this line here, is more steeper downhill, more steep downhill, then you are correct. That tells me that this one is, well, more steep downhill. So even though this slope is negative, this one is more negative. So if we were thinking about a number line, if here's 0, this is negative. More negative would be out here somewhere. So if we were going to line these up, the more negative slope, which is f prime of 4, would be here, and the less negative slope of f prime of negative 4 would be here. So let's start with those two. Okay, so I'm going to make a box to line these up in just so I don't use that space for anything else. Okay, so I know that f prime of 4, is more negative than f of negative 4. All right, so I've looked at this one and this one. And now let's see, are there any more negative slopes? At -1, clearly the slope is not negative. What about at +1? Clearly it's not negative. So at this point, these are the only negative slopes. And excuse me, I just wanted to move this so none of our lines are crossed out. So are any of these slopes 0? Well, let's see. At f of 0, the slope of this curve, that means at this point that intersects, that is the point 0, comma g of 0 here. The line intersecting that point is traveling uphill, so it's not equal to 0. So I'm going to ignore this one for now. Let's look at 2. Oh, look at this. The slope here at the point 2, comma g of 2, the tangent line through it, remember these are tangent lines. The tangent line through this point is horizontal. That tells me the slope here is 0. Wonderful. So that one I'm going to write down. That is a really important one. I'm going to go ahead and sketch that out in pink, this slope here. And write horizontal tangent. And to be specific, slope of tangent is 0 here. And remember, the slope of the tangent is the same as the slope of the curve at the intersection point. So that means our curve is flat here. So f prime of 2 equals 0. So then certainly we know that f prime of 2 belongs here. Remember, this is like a negative 1.36. This is not as negative, and this is 0. All right, so we've taken a look at this one now. So we just have 3 positive slopes remaining. So f prime of 0, I'm going to go ahead and sketch my tangent line there. And you do that by getting a ruler and tracing it. It's positive, and that looks like it shares the same slope. There we are. Okay, so that's one of them. Let's look at f prime of -1. That's here. So let's see. This one looks to be about, there we are. And now let's do one more, and that is f prime of 1. And at 1, our curve looks to be doing this. There we are. Okay, so this is the tangent through 1 comma f of 1 here. Here we have the tangent through 0 comma f of 0. That's here. And then finally, we have the tangent through -1 comma f of -1. All of these are positive, so now you have to ask yourself, we want to go from smallest slope to largest slope. So think of it in terms that this has to be the steepest, and this is the least steep. So which of these is least steep? So if you're walking uphill, which of these 3 curves, this one, or this one would be the easiest to walk uphill on? If you said the curve through f of -1, you are correct. So f prime of -1 right there. And then the most steep curve, the one that's going to go last because it's the largest, passes through f of 1. So that's f prime of 1. That leaves just f prime of 0 here. All right, so if you notice, you don't actually have to estimate all of these slopes like we did for this first one. If you think you'll struggle with visually seeing and being able to determine which one is most steep and which one is least steep, then I suggest you do this method. That is, always pick out 2 points on a curve. So in this case, I could pick out this point here. So my rise down is like -2.5, and my run is 3. So it would be -2.5 divided by 3. And that's for f prime of 4. And you'll get a number that is smaller than -1.36, excuse me, larger than -1.36, but smaller than 0. Its absolute value would be smaller. Otherwise, you can simply take a look at the curves and see which is most steep and which is least steep. Now, I hope you keep calm and math on.